Hi, hello and welcome to week 7, Einführung in die strukturierte Programmierung or Introduction to Programming. Hello Alex,
Hi,
again
David.
today again on the usual place.
Yeah, but for the last time, actually, next week we will sit side by side, actually.
We are not sitting side by side now. Wow.
Physically
Yeah,
side by
I'm
side.
very looking forward to that next week. So
Yeah,
prepare yourself. Next Thursday we are in person, virtual in person next to each other.
right.
Great.
Yeah, and
So I
today
hope
we
you can
will
also hear us. The chat is quite quiet.
quite quiet, yeah.
Are we online?
I think so.
Yeah, seems so.
Yeah, wasn't there like an
Okay.
exam today? Maybe just still overwhelmed the exam.
Okay, yeah, I think we can start.
All
Everything
right,
is
that's good.
great.
That's good.
So, Alex, what are we talking about today?
Um, Own data types, which is pretty cool because we're talking about the way to create our own data types in a way to make our programs even easier, clearer, whatever. And there we will show you some cool ways to do that. Actually, structs will be a huge topic for today, and enums. And as always, we will talk a bit about memory. But before we go into that, I think we have some organizational announcements and some hints and tips regarding the assignment 2.
Yes, correct. So, as you might have seen, we have extended the deadline. Also, Michi and Julia mentioned it, but we also want to mention it again. So, we have extended the assignment 2 deadline to Monday, the 11th of December. So 5 days more, but as you can see here, please start early. If you haven't started yet, start now, start really today, because it is quite challenging and it is, yeah, much code to write. So please do not use this deadline extension for just procrastination. So really just start as soon as possible if you haven't started yet.
Yeah, right. And we have really a bunch of support options. Use them. So even if the assignment might look a bit harder, I mean, compared from A1 to A2, this is a transition, and we always have this transition between assignment 1 and 2 or assignment 2 and 3. It always depends where we introduce dynamic memory management and also a bit pointers. So these are usually the concepts where complexity really increases. But in the last years, we just had the Teach Center forum for support, and this was from the response levels from the tutors not comparable to what we're having now with our dedicated Discord server. So please use the Discord server. I'm overwhelmed by the support that the tutors actually give. There's not a single question which remains unanswered like for 15 minutes during day and night.
Yeah.
So please use that. We also offer a couple of personal question hours on Discord and in person, and use it. Come with questions, and even if you're not sure how to start these things, ask on Discord or go to question hours. We all really want to help you. There are no stupid questions. Just do it. Just come. Just help yourself by asking tutors, ask the lecturer team, and we're really here to help you.
Exactly. And if you don't know how to start, maybe I can give you a few hints or a few ideas how you could approach the start. So, for me, on my perspective, the divide and conquer is the thing you have to keep in mind because it's a huge assignment description and you have to divide it into subtasks. So, first, and we tried to also write the assignment description like that, that it is really divided into subtasks. The first subtask is user inputs, and I will talk next slide a little bit how you can approach the user input. Then, if this user input works, then start with the stating farce. And then, if this works again, do the running phase, and then if this works, do the final phase. So really try to divide it into subcomponents until you can, until you are able to, solve the problem. And before you start, I think it's a good idea just to make yourself familiar with 2D arrays. Watch the practicals from today. They are very important. Michi and Julia showed there some very, very interesting and very helpful concepts. And from my perspective, it was also very helpful to write my own small example programs. So just create your own program where you want to allocate memory from the heap with a fixed size, for example, and then write something inside. And if this works, you can extend it. And if this works, you can extend it even more, and so on. So step by step, creating your program and start very, very small. Another tip is use our coding exercises. I've linked it here, and you can also find it on our course website and also on GitLab. There are tasks, small tasks, let's say about 50 lines of code, which, for example, use dynamic memory or use two-dimensional arrays. And we also provide there a solution. So if you're unsure, if you do not know how you should approach it, look at this assignment or at this coding exercises, and you have a possible solution there. This could also be very, very helpful for you. So as I said, we want to divide it into subtasks, and if you think you have now wrote a few programs, you can, you know a bit how 2D arrays work, how the heap works, then it's a good idea to start with the assignment and with the user input. And at first, of course, you have to read all the things from the user input. So it's the hotel name, the number of floors, the number of elevators, the capacity of the elevator, and the number of waiting people. So here, my opinion, fgets would be very, very helpful. You have to check for a valid input, and we highly recommend that you write your own string functions. So we said you're not allowed to use string.h, but you can write it on your own, and they are not that complicated. So for example, a string compare function can be written in, let's say, 5 to 6 lines of code. It's not that hard. So I think you need to compare strings to define the length, how long is a string, and so on. So write your own functions. And first try to implement the first user input. I think it is the hotel name. And if this works, go to the next input, the number of floors, the number of elevators. And every time you have done, or you have read the user input and you tested it, because we allow a certain range of input, and if this works, then you can continue with the next input. And if all this, let's say, basic input stuff like the hotel name, the number of floors, elevators, capacity, and so on, then, in my opinion, the first problem would be the destination floors, because we need for each floor to store the destination of each person. And the keyword here inside is this for each, and also this of each. And if we can describe a problem with for each floor, store destination of each person, it is most likely that we need a two-dimensional array for that. So it is two-dimensional data for each floor. We need information of each person on the floor. And my tip for this is try it first, as I said before, with a fixed size defined by yourself. On my perspective, it was also very, very helpful for me to really draw on the paper a two-dimensional array and then really just put in numbers and write the code to this, and then have a look if it is what I think. So I think first semester ESP was, I needed more pen and paper than in all the other semester together. So it's really just think about how it is implemented and how you could approach it.
Yeah, I agree, especially with the pen and paper approach. This really helps. Or I don't know, whiteboard and draw yourself some things. This really helps you with programming and to get an idea. 2D arrays or structs, what we'll do today, or linked lists, which we're going to do next week. These are typically concepts that are easy to understand if you get it visually. So yeah, try to draw them. They're really easy to understand when you have like them in front of you and then can like play around with values. So this is a really good tip David give you.
That's also the reason why Michi and Julia in the practicals always draw something, because if you visualize it, it's you just get it much easier than just writing the code, because an array inside the code, then accessing it through a for or a double for loop is quite hard to understand, but if you visualize it on pen and paper, it's so much easier, I think. Okay, so let's assume you have all this information now. You have the destination floors, you have all the hotel name, the number of floors, and so on. So until here, everything fine. You have the hotel name, you have the number of elevators, you have the number of floors, and you have the destination floors. The destination floors, as I said, is for each floor, there are many persons, so it might be a good idea to have a two-dimensional array for that. And what we need now is, we missed the elevators themselves for now. And again here, for each elevator, we need a maximum of C people inside, where C is the capacity of each elevator. So we have again here a two-dimensional information, because for each elevator we have maximum, let's say 10 people inside. So we need here an array with the dimension number of elevators times capacity of each elevator. And again here, if you draw it, I think it's much more easier to understand. And if you have implemented this, in my opinion, the most tricky thing is already done, because you have it, you have all your data structures now working, and then, yeah, the goal is to print the initial state. And if you have reached this goal, then it's just that comes for me the funny part, because you have to implement some logic. But in my opinion, this starting phase is really the hardest one. A few tips from my perspective. Start, as I said, with a fixed size array and allocate, for example, a fixed size on the heap and try to get it up and running with this fixed size array or fixed size array on the heap. And if this works, then you can change it to a dynamic size depending on the user input. But try to reduce the problem as much as possible. You have just one array on the heap, and then if this works, go one step further, and if this works, go one step further, and so on. And if you have then your initial state printed, test this for many possibilities, so for many elevators, for different kind of a different number of floors. And if this works, then you can go to the next step and starting the elevator game or running the game. So this was my short ideas and tips from how to start with assignment 2. I hope it's a little bit clear now, and as Alex before said, we try to give you as much support as possible, so please use it, and if you have questions, also ask them on Discord or at the personal question hours.
Yeah.
Are there any questions left?
If you have questions, please just drop them in the chat. Even if it's like a conceptual question, how could I do this and that? We won't give you the exact solution, obviously, but what we can do is to give you like some idea in which direction it might go and what you could do. You can also do this on Discord or at the question hours to like get a sense on how to start with certain things.
There was one question, not really a question, but a statement. The hardest thing for me is to move the elevators. Yeah, sure, that's a very hard one. But if you reached the movement of the elevators, you have all this starting phase done. So congratulations to that. And just try to imagine you have or start with one elevator, which is basically just one array then, or one-dimensional array, and think of one elevator to move. So move only means that you have, for example, the elevator at index 0, which means it's on the ground floor, and move means the elevator at index 0 should be nothing inside, and the elevator at index 1, then there should be something inside. And this is the move command you have to implement. So basically it's just removing from one index and then print something on the next index. This is what a move could be.
There was also a question how the hotel might get printed. This might be a bit tricky since the hotel name and everything has to be aligned correctly. I would, if I would program this, try to also divide the hotel in different parts. There are dynamic parts and there are more static parts. So dynamic parts means like the floors, these things, and static parts like the top, the bottom. The name is a bit in between, but I would say it's also more static. And I would try to actually divide these things and say, okay, these might be something static, which is like the top of the hotel, like the ceiling or whatever, and also the bottom of the hotel. And between that, you're doing like the dynamic stuff of that. So this would be my approach, actually. David, what do you think about that?
Yeah, totally agree to that, yeah. There was also one question. So you said first try to do the logic and afterwards try the printing part. No, I meant it in the starting phase. So as soon as you have all the things read, I would recommend to do the printing and print the initial state. And if this works in different kind of possibilities, so with a different number of elevators, so if this works, then I would go to the logical part where the elevators can move.
Yeah. Does the name need to be centered? I think so. It doesn't have to. Yeah, it has to be centered, but it depends. I think this is very good explained in the assignment description, David. Right? So there
I
is.
think so. I don't have it in mind now, but please, if you're unsure, just write on Discord, and we can give the more precise answers.
There should be the rule on how to align it exactly. Should be managed to do that. But yeah, the hotel name is centered in the top segment of the output. If an exact alignment is not possible, the hotel name starts one space to the left. So actually, yeah, it should be aligned central. What else do we have? Do we have to use const for all the different symbols of the print? I would say so, yeah. So it makes sense to have all the like hard-coded values in a define or a const. I would say that makes pretty good sense, and then you won't get like a loss of points for hard-coded values. And then also, this is a cool question from
I think Michi and Julia also talked about it. So you are allowed to split it into multiple files and also use header files. Yes.
So you don't have to actually. If you don't know how to do this, since this is like your first year of programming, you don't have to do that. We will do this anyhow next semester in object-oriented programming. But here it's also fine if you just have it one main file. But if you want to do this, to split it up in multiple files to keep it more readable, you're more than welcome to do that actually.
Great. Yeah, I think we have to do a short recap from last week also, Alex, right?
Sounds good. Sounds good.
So last week we talked about the memory layout, we talked about the stack, the heap, data segment, and the code segment, and mainly we talked about the heap because of dynamic memory, and also Michi and Julia talked about the dynamic memory today. So short recap, the difference between the stack and the heap is on the one hand availability. On the stack, variables are available until the end of function, and on the heap they are available until you free it, because as you might have seen before in the practicals, you can, for example, return an array on the heap from a function and it's still available then, because you have to free it then when you don't use it anymore. And when do you use them, stack and heap variables? So usage of stack is most of the time if you know the size at the compile time. So if you know the array has always, for example, 10 elements inside. And if you do not know the size, the heap is the way to go, because it depends, for example, the user input, as we have at assignment 2. It can be arbitrary long, can be you don't really know how big the array, for example, would be, and then you need the heap for that. And we also have seen that memory on heap is available until we free it, as I've said. So in this case, we have here a create array function from last week. We used calloc, and we get a pointer back. We ask here for, or we check if it's null, so if it worked. And then when this here is the stack of the create array function, we return this array. We have to check for null. And when this function here returns, this pointer is copied back into the main function. And the stack here is not available anymore, but it doesn't matter because my array is still available and I have the pointer for it. And then I call free. So free means there is no memory here. And when I say array equal to null, then I also destroy, let's say, the pointer to this memory location. And we talked about malloc, which allocates memory which is not initialized. Calloc is the same as malloc, but it initializes the memory with 0. Realloc changes the memory size, and we will also have a short example in a few slides about that. And free, which is very important to free the memory if you don't need it anymore. So I think last time we didn't talk about realloc that much. Michi and Julia did today in the practicals, but I just want to show you something. How to maybe use realloc. We have here malloc, and we say, okay, we need 3 times the size of an integer. Then we get here a pointer back. We check for the pointer, write something in there, and then we thought, okay, we need more space. 3 is too less. We need maybe 5 times integer. We use realloc, so we make it bigger. Check again for null, and then we can write here another things. So I know this would be better to store in a temporary variable. Michi and Julia talked about it, but I haven't had that much space, so I used this one, but it is not the best solution. Keep that in mind. That can be problematic in this case. So let's say we are here now in the program, and we have written here 1, 2, 3 inside my array, and this is just some random number which is next to my array, but I do not own this because I only have these 3 memory locations here. And then I come to this realloc, and here I need 5 memory locations, but I can't use this because maybe this is just another variable here. So what realloc does, it finds somewhere else space for my memory, copies all what is currently inside, and then creates this bigger memory for me. So the second argument is the new size, and I get back a pointer to this space here, to this memory location, and then I can write here 4 and 5, for example, inside. What would happen if we forget this? So if we do not get this return value from realloc, any ideas what might happen in this case? Yeah, it's a good question from Toki. Why doesn't realloc automatically free the old address when it fails? That's a good question. Can't really answer it. Might be an improvement, yeah. Pointer gets lost, yeah. That's a good idea. So if we have something like that, we just hand it the pointer might point to addresses which I do not own anymore. And when I then exit this like this and say I want to write 4 and 5 here, maybe I overwrite memory which I do not own here. And this can be problematic because maybe this is another variable I have on the heap and I just overwrite it because I didn't catch the right pointer here. So keep in mind you have to catch the return from realloc, and as I already said, would be even better to save it here in a temporary variable, check this for null, and then write grades is equal to temp to get then the new memory location. That would be perfect. All right, were there any questions, Alex, about that?
No, I think we could answer everything in the chat.
Great. Yeah, command line arguments. So
this is something really cool, actually.
Yeah. So
we learned about,
maybe this is what everybody knows until now, hopefully, especially at the assignment interviews, you have to write it. There's a command and there are arguments. And the same is also possible with our program. Right, Alex?
We can do the same, actually, yeah. And this is really handy because then we can pass external information within the program. And this can be really helpful in many cases, actually. We can parameterize our program.
Exactly.
And yeah, you did that here. And in C, this is quite easy. We don't have to deal with too much because we know actually all the stuff already. Maybe you have questioned why we're writing void sometimes not, because sometimes we just forget it. In the main, we just say there will be no argument. And I mean, you can now question yourself or question like everyone. Who should actually pass information to void, to main, and this is actually what the command line arguments are about. We are passing information from outside, like from the terminal that we're opening, where we were calling the program, to the program. And on the right side of the slide, you see actually that we have two arguments that main takes here. I know for all of you that are more into C and into command line arguments, there are different possibilities, but these are actually the two most commonly used that we use here now. We have two things. First, the argument counter, and second, the argument vector. And if you have a closer look at it, you actually see the first is an integer, so it counts actually the arguments. And the second one is an array actually of strings, or like strings in an array. So you can actually access them. And we will show you this in a minute. Right.
Yeah.
Here, cool thing, we have a text saying, okay, this is the number of arguments, and then we have a loop that runs from 0 to the argument maximum number of arguments, so to the argument count, and we just print them. But before, yeah, it's okay.
Sorry.
No worries, no worries. We could have timed that better. I mean, it's my fault. I just want to say the interesting thing is always that the first argument or the 0th argument in a command line argument is always the program itself. And this is sometimes a bit, yeah, it gets forgotten sometimes, that you should also mind that. And here you can see quite illustrative. So we have number of arguments 4, but actually in my world, when I started C or programming, it were 3 because I have 4, 6, and hello. But C interprets the first argument as the program name. So you have actually 4 arguments, not just 3 of them. I hope this makes sense.
Yeah. And you can give any type of information there. So as you can see, we gave 2 integers, 4 and 6. And then we can also give a string to it. And all of them is stored as string. So this 4 is a string. This 6 is a string. It's just with the number 4 and 6 inside. And this hello, of course, is a string.
Right.
Yeah. But yeah, there's one thing you should do in the beginning of every program if you use arguments, or if you would command line arguments, and that is to check if the program is called correctly. Because imagine you do not check it and you maybe just do something like this, you count over all the arguments, and then it might be problematic because the program is called wrongly and you're out of bounds, you're out of range. So I think it's always a good idea if the program is called with the correct number of arguments. In this case, we only allow program calls with more than 2 arguments, so the program and 1 additional parameter. If your program only allows exactly 1 parameter or exactly 2 parameters, you should specify it here. That's very important way, I think.
Right. There was this discussion in the chat also with int main void is the newer syntax. So actually, the C standard says that you actually should do the void version. It's working. Both versions are working in C. In C++, which we do next semester, there is actually no difference. It's something, or some people just say it's i-Tüpfelchen-Reiten if you put the void into the argument list or not. Honestly, if I don't forget it, I do it. If I forget it, the world still spins around. So yeah.
Yeah, me too. I tried to think on that, but sometimes I forget it.
If you want to read the technical differences, there are like 1,000 Stack Overflow or Quora or whatever Geek Forum posts where you can actually check the differences in detail. They are not relevant for the course here, actually. It's a very C-specific thing.
And yes, from the question in the chat, so argc is set automatically, and also this argument vector with all the strings inside is also set automatically. So as soon as you call it like this, you will always be possible to get the argument counter and get the arguments. So you don't have to do anything more. Just the first argument from the main is always the counter. So how many arguments did I receive? And the second argument is always this 2-dimensional array of strings. All right. Yeah. It would be good, because all these arguments are strings, to somehow convert maybe this 4 and this 6 into integer, right?
Would be cool, yeah.
Would be interesting to can do that. And of course we can do it, and it's something called type conversion, or also casting sometime. But in this case, we need a type conversion because there are a few functions which already do that. For example, if you have, let's say, this string 1, 2, 3, you can call a function atoy, which is ASCII to integer, or also tof, which is ASCII to float. A little bit hard to pronounce, but it works like that. And you can, as you can see here, just giving the string, it returns in this case an integer, and then you can work with it as it was an integer. The same for strings, and also for any other data type this would work. So this is the conversion from string to integer or to float. But for example, can we also convert an integer to a float variable? And yeah, of course you can do it, but you have to be a bit careful sometimes. For example, if we have something like, let's say, an integer 4 here, and then we say float y is equal to x, and we print this float, this works. There is no compiler warning or error, and this is called an implicit casting because the compiler converts the type from an integer to a float. We can also do a so-called explicit casting by writing in parentheses here the data type we want to convert the variable x. So this is really the where we say casting. The programmer use this cast operator, so this parenthesis, to cast the variable here into another data type. In this case, it works without any problems, but let's suppose we have something like this, maybe a question in the chat. Is there a problem? And what could be the problem, or what is the output here? Too big for a jar, yeah, that's correct. So for characters, we have a range from 0 to 255, which are 256 characters, or 256 symbols we can represent. And when we have higher numbers, we start again with 0. So in this case, we have 257. We can go to 255, and then we start by 0 again, and then we have 1. So the output for here is 1 when we cast this integer to a character, write it into a character, and then just print the character or the number of the character. So you have to keep always in mind, do I lose information with this casting? Because sometimes it's not a good idea to do castings. To do casts. Castings is something different, right? All right, what might be the problem here in this case? It can't store a floating point, yes. That's correct. Of course, we know float can have decimal places, but an integer can. So we have this pi, cast it to an integer. The output is just 3, so all the decimal places were removed, and the integer cannot hold it. So again here, The takeaway from you is only cast if you're sure you do not lose information, because most of the time you do not want to lose information. And yeah, it might work in the other way, so we can cast most of the integers in float, but casting float to integer is most of the time not a good idea unless you really know that it has no decimal places. One more question here. What is the output of this? So we have a string, 1, 2, 3. We cast it to an integer, and then we print the integer. Any ideas? The ASCII value of 1. Okay. It is something really odd. This is just an example. It might change, or it will change all the time you execute it. And the reason for that is we cast here the address of the first element, because it is really like a child pointer, pointed to the first element. So we cast here the address to an integer, store the address as integer, and just printing the address as a number. And that's why we used this a toy before, because if you do it like this here, it won't work, because you are casting the address and not the value. This is of course a problem. And this is maybe a more advanced topic. You can also of course cast pointers. Sometimes it is very useful to cast pointers. Maybe, so this is a short example, does not really make sense, but it demonstrates something. If you have here a number int and a float called floaty, you can call the same function, which takes a void pointer and then set it to 0. And you can take you can take both variables, cast the address to a void pointer just to hand it over. There it is set to 0, and this works. The output will be in both cases 0 then. So of course this does not really make sense, but I want to show you in a short example. You can cast something to void, especially for pointers. It is most likely, or sometimes it is reasonable to cast something to void, because this means you can choose any other data type. And in this case, this function can use any data type, can be called with any data type, so it can be a casted integer or a casted float or whatever. All right. Are there any questions to that casting part, Alex?
Actually, that it's a bit confusing, and yeah, casting can be a bit confusing, especially when you did the casting. Actually, in many programming language, actually, the casting is done by itself, so you don't have to consider casting too much. In C, there are some cases where it might be handy, but actually you will come quite far without casting in C at all. In some cases it really makes sense, like with pointers, to do that, but yeah.
So if you do a conversion from a string to integer, yes, but castings is most likely done or most often done at pointers, when you have a void pointer and you want to convert it into an integer pointer or to a float pointer or whatever. This is maybe the most use case here.
Cybertom, that is a good comment, and I think in the next slide we will have actually an example about that. So I have here the function prototype of malloc, and so this is from the documentary, and what we expect from malloc is that it returns as a pointer. We talked about that last time. But what it really gives us is a void pointer. And as we know, void means arbitrary or nothing or whatever, yeah. And so what we actually get is the void pointer, and we could cast this void pointer. We just show you that it is possible, and this is a way to do it. But actually, I wouldn't do that here, because with this arbitrary pointer, we can work anyhow. So this is just to show you that this could be done, but we don't say that you should do this actually all of the time. As you can see here, we will get a void pointer, and what we're saying with this int pointer is that we want to cast this void pointer to an int pointer and write it here into this integer. We could do this even without this casting that we just did there, because as always, as we also said, it's an arbitrary pointer, so there is no need to implicitly cast this because it's working anyhow, because it's a pointer same size as we know. So we can also work with that, and we should do that because otherwise it gets somewhat confusing also.
Exactly, but yeah, sometimes I also write it like this, just to make sure for myself that I really want to convert it, to cast it into an integer, because sometimes maybe I don't really know what I want to get here, and in this case you can make sure that you get the data you really want to get.
Right.
So this cast maybe is really for the programmer more than for the compiler, just to get or to make yourself sure that that is what I want. All right.
I think we talked enough about these things. Yeah.
yeah. This very, very confusing casting. I know casting in the beginning, especially in the beginning, all this pointer, int pointer casts and whatever, they are very, very confusing. So I think enums are now much more easier to understand, in my opinion.
Definitely. So everything that comes now is less confusing. We will promise.
Okay, perfect. So think of something like this. You want to represent the days of a week. Of course, you can use this define, but all these days have something in common. They are days in a week, and this is not the best way to write it because you can use an enum for that. And using enum is very convenient because first it is less to write, in my opinion, because you don't have to define all the variables here. Just write enum and then Monday, Tuesday, Wednesday, Thursday, Friday, and so on, and you can use it like a constant here inside. So when we write something like this, the first element is always represented with 0. So if we print the Tuesday, the output will be 1 because it's 1, 0, 0, 1, 2, 3, and so on. So these are the possible values, and they are automatically assigned starting with 0. I give you a table where it can just show you the value and the name. So this is a cool way to write it, and you can also use, for example, values for it. Let's say the Monday should have the value 10. And as you can see, then all the values have +1 value. So Tuesday have 11, Wednesday have 12, and so on. So this is also a very cool way that you can start with it. Maybe you can also use an enum for ASCII characters. So you can set the start at the first value, but what you can also do with enums is that you just use like arbitrary values. So the Monday should have the value 10, Tuesday should have the value 2, And these are then the values here, and you can stop. Let's say Friday has the value 34. Saturday, Sunday, you do not define a value, and then they are just as before, the next value are automatically assigned to them. So here we can set different values, and there are two types of enums. So until now we only used this enums without a tag. So just write an enum and then with this curled parenthesis our elements inside, and then we can use the element name. But maybe the even more interesting way is to use a tag. You can write here between the enum keyword and all our values a tag. This is we use this underline, this underscore here because it is like in our style guide defined. So please also, if you define an enum, use this notation. And then we can use this enum also as data type, and that's very cool because you can then define like a type. You can write enum weekdays, the current day is free, and then you can calculate with this. You can of course also say instead of free, the current day is Wednesday, for example, or Thursday in this case would be free then because 0, 1, 2, 3. You can also write here Thursday instead of free. So this is the data type again. But in my opinion, it would be easier to just write weekdays instead of this enum underscore weekdays underscore.
Yeah, definitely.
That's not very pretty. And I want to introduce now another cool feature which is called typedef. And typedef can be used to create so-called aliases for data type. So you can write, for example, typedef unsigned character byte. Then you can use this here, this new name, as a current existing data type. Then you can write, for example, byte B is 4 and so on. You could also write typedef char pointer, which is my existing data type, to a string, and it would be much more convenient, in my opinion, to write or to have something in the C library. You just can write string, and this really works like a char pointer in this case. So maybe I think we also have already seen some typedef when we talked about size t, because we also said that size t is just a long unsigned. And yeah, in the background, in the standard library, long unsigned, so there's just one typedef which said long unsigned, size t is the new name, and then you can use this size t variable. And coming back to enums, we also can use this typedef for enums and say typedef, then this existing data type, and then we can in the end here add our new name, our new data type we want to introduce. Then we can really use this data type as it is like, I don't know, an integer or whatever. So this is really cool because we can use it not only here, like creating or initializing a variable, we can really use it as a data type. For example, we have here a function which takes a weekdays, so takes exactly this data type, for example, a Monday, then it increments the day and it returns again a day. So we can write here today is Thursday, next day, and I hand it over today, and I go back tomorrow, then I can print tomorrow and the output is 4. So we can really work with them as they are data types, and that's very, very useful because it is so much easier to read, in my opinion, to read how, or to read we know that this program is about days of a week, and if we only have here integers instead of this own data type, it would be much harder to read, in my opinion. You're very busy in the chat, Alex. Are there any questions or?
Maybe pick a few things. Can you also print the weekday itself or only the int? You can just display the int because it's just an enumeration. So behind this label, there is actually just the integer value. And the cool thing, so maybe you ask yourself now, why do I need this actually? It makes things more readable. If you did the homework 2 now, homework 2 with this seat reservation plan, then we had zeros, ones, and twos, and zero was reserved, and then we had free premium and free regular and stuff like that. And I just pasted this into the chat. Actually, instead of that, you could say, for example, you have the enum status, and then you can write things like free regular, as I did in my second message. And then you can access like the value 1, but with this super handy label, because then you know, okay, this is free regular, and so this makes more sense to read than probably 1 or something like that. So this really helps.
Yeah. It's also very cool if you have, let's say, 5 different return values of your program, which are defined in the assignment description. Just create an enum, give them a name, and then you can use this name at the return statements, and it's much clearer that you know, okay, in this case we are out of memory, in this case this is a problem, and so on. So also with error handling, these enums are very useful. And of course you can also cast them in your own data type or cast these enums whatever you want. So C is has no many limitations in this case. It's really up to you what you want to do. Great. So the advantage of enums are, as I already said, you can compress numerical constants which are related somehow together, and the main advantage for me, it improves readability significantly, because you have not only these magic numbers, this value inside, you have a string, really a text, not a string, but a text as a variable where you can see what this value means. And it's also type safe with enums, so the variables can only take predefined values, which is also very helpful here. All right, we have 15 minutes left. I think we should go to structs now, Alex.
Yes, let's do some structs. Okay, so enums are nice, enums are great, but structs are the really cool thing. Structs help us to structure somehow our own data types. And what a struct actually is, it's a group of variables that we put under a common umbrella, more or less, and have a own defined data type. Let's move on to an easy example. We have a person, and we have a name, a birth year, for example. And so what we actually want to do now is to write some kind of data type, and therefore we use the term struct. And by using struct, we can actually say, okay, we have a person with 2 members, and these members are name and birth year. So a person has these 2 attributes, which we call members, and also again a tag. Now we need to refer to this person, or like to this data type actually. And let's move on to the next slide. We have a person here, and now we want to declare this person and initialize this person. And so we're saying, okay, struct person, person1, and then the next step is the right, is here with the curly brackets where we assign the value to this person. And we're saying, okay, the name is Victor Timely, and Victor Timely is born in 1901. And so we set these values in the struct. And the cool thing that happens here, we don't need any string copy here, which you might expect, but we don't need it because we're just saying, as with string declaration or like character declaration, we're just taking this read-only value and write it into the array to initialize it. And this is super cool because now we can access this person. So we're having a person, and this person has these two attributes. And by saying person one, period name, underscore, this is just a notation with the underscore, we can access the name and also the birth year, of course. Yeah.
So that's, I think, very, very important to understand. And structs are a very important topic. So please try to understand it, because we will use it, I think, nearly the whole next lecture. There are so many cool things to do with structs. So when we create a person, in this case, you can initialize the person like this, and you can then access the member variables of this person using this point here, to get the name and also to get the birth year. So structs in general, I would describe it, you have some variables again. You could also maybe just write name and birth year as extra variables, separated, but they are binded to a person. So if you have variables that belong together, for in this case to one person, then you should use structs, and they make it so much more convenient, I think.
There's a really good question in the chat. Is this OOP in ESP? Kind of.
Yeah.
So this is the idea of that is somehow inspired by obviously encapsulation and putting information together. But as with classes, for example, in object-oriented programming, we don't have any methods, for example. So yeah, we will talk about this in the next semester in object-oriented programming 1 a lot, but at least we get like some attributes, some data.
Yeah, exactly. So it is, you can imagine it for like a very, very reduced class, but I don't want to say too loud. Yeah, and also there was in the chat the question, is this globally? Yes, so the definition of structs, you can do it always global. So this is allowed to define globally, but of course not the person. Then the person should be inside a function, but the definition of the struct can be global. Yeah, so we can also extend it a bit. And now it's get a bit confusing, I think, but that's always the point where it's get even more confusing. A struct, or a struct person in this case, a person can also have struct members inside. So a person in general have a mom and a dad. And so in this case, you only have not only the name and the birth year, but also a pointer to another person, which is the mom, and a pointer to another person, which is then the dad. And they are, of course, also from the data type struct person, because they have again a name, they have again a birth year, they have again mom and dad. So that's very important. They do also have the same attributes. So you can think of, if you define it something like this, you have here again the person with name and the birth year, and you have then a pointer to the mom and a pointer to the dad, which again is a person. And you can write it in this notation here. So just the first argument you're giving here is the name, the second argument is the birth year, and we initialize mom and dad with 0, which means they are not pointing to person in this case, they are really pointing to null, but we can change it afterwards. But what you also can do is you can write something like this and explicitly say, I want in the name member, I want to have this name. You see here when you use the same point here to address the member, the birth year should be 1901. The mom should be 0 and the dad should be null again. So both should be null. But again, here maybe we want to write person instead of this struct underline person underline. Anybody has an idea how we can solve this? Is there a discussion about Marvel, I think, currently, right? In the chat.
I started one, but not just that one. So there's actually other content also running on. So it's not just Marvel.
Okay.
Usually whenever I mention these things, it turns into a Marvel discussion. This is always the case.
Don't worry, I continue with the lecture and you just keep the Marvel discussion ongoing.
I will fanboy a bit over Marvel, yeah.
Great. I've seen it in the chat. We can use typedef again and say typedef, then we use this struct and the new name after this curly parenthesis here. So this then makes it much more convenient for us. We have here a typedef struct with the person, and then we can write person p1, for example, as we have seen before. And this is again a data type. We can return it from any function. We can hand it over to any function. We can create pointers and so on. Talking about pointers, maybe we can also go to struct pointers now. Because, as I said, this data types like a person is just a data type. We have here now the King Charles. So sorry, Marvel is over now. We go to Britain, King Charles, and we take the address of Charles and write it then into a person pointer. And we want to again use the point to get to the birth year, because this is wrong. We have to get the right year. But when we do this, anybody has an idea what's the problem, or it might be a problem then?
I think someone mentioned that already in the chat earlier already.
Yeah.
But
they're too fast for me to read, yeah.
Yeah, no, Tweenie did that a couple of minutes later.
Okay.
Or earlier.
Yeah, dereference it. That's correct. Because if we do it like this, we will get an error message from the compiler. And the error message is very precise indeed. You have a person pointer, which is aka a struct person pointer, because it's typedef. And it is a pointer. And if we do something like this, it won't work, because this notation with the point only works when it is a variable and not a pointer. So when we write here Charles dot birth year, this would work. But this Charles pointer, because it is a pointer, this won't work. We have to dereference it again. So this Charles pointer is a pointer. So we have something like this. We should dereference at first pointer to get the value, and then we can use the point to get the birth year. but this is hard to read, and there is a better notation for that, which is in the beginning most likely even more confusing to you, but it is the way to go. You use this arrow operator, which implicitly does the same like here, dereferencing and then accessing with the point operator. You can also, and you should also write it like this. So this operator here really means dereferencing the child's pointer and accessing the member birth year. Very important to keep that in mind, because this is next week we will talk a lot about this. We will create our own lists, linked lists and binary trees and whatever, and there we will work a lot with pointers, I think. All right, a few slides left, but we are very good in time. Let's say we have this struct pointer. In this case, I created William, so this is Prince William, born in 1982, and has a mom pointer 0 and a dad pointer 0, a null, so null, not 0, null in this case. So I haven't defined it yet. What happens if I access William.dad and then arrow birth year? Any ideas what happens here? Segmentation fault. Yeah, that's true, that's correct. And the problem here is, so when we access William and we go to this dad member, so this is the dad member, but we set this dad member to null here. So we are dereferencing null. So this is really null. This is not a valid address. And then we get the message segmentation fault. So you access memory which you should not access. There is, at the segmentation fault, there is a problem with your program. This should not occur. What you should do instead is, for example, creating Charles, then creating Diana, and then you can create William, set to null, and then say, for example, William.dad is the address of Charles, William.mom is the address of Diana. Of course, you can also write it here if you want. And then the access would work to go from William to his dad and edit the birth year of King Charles. So as you can see here, you can go through and go from one person to another. So we start here at the child, the William, then we can access his dad, and if we had defined a dad of King Charles, we can access his dad and so on. So we can iterate very easily through all these persons which are connected then. And this is very important to keep in mind for the next week. And I think we are perfectly in time, right?
Yeah, and what is also cool, David, you just easily introduced a binary tree to be more precise. So you might know it from other lectures probably, or like from your prior knowledge in computer science, but this is actually what a binary tree is about, and you will do this a lot of times during your study program. And next week we will also talk about these things. But these data structures are really cool, and you can do really cool stuff with them.
Yeah. So I would say today was the foundation for next week, when we can do advanced data structures with structs. So next week is most of the time we talk about structs and what we can do with this.
But honestly, I mean, David, if I don't miss anything, I think like from the concepts in C, we are actually more or less through with most of the things. I mean, file IO is still missing, but next week should be more combining all the things together. But besides that, I
Exactly,
think
yeah.
we got everything. So yeah, actually next week will be a combination of structs, memory management, this data structure concepts that we just mentioned today, and file IO,
Yeah.
which is also cool because next week we will talk how to read files, write files, and actually have persistent information at some point, because everything now is quite boring. When we run the program, it's done actually after it.
Exactly. Yeah. So next week will be the
Right.
merging all our last lectures together into one big concept. So would be will be very interesting then. Great. So what we have talked about today was the command line arguments in the beginning. So if you want to give additional information to programs. We also talked about casting. Could be in the beginning a bit confusing. We know that. Then we talked about enums and typedef. Typedef is very cool because you can create your own data types with it. And in the end, talked about structs. You can group your variables. And what is missing here is in the beginning, of course, we invested, I think, 15 minutes to talk about assignment 2, give you a few hints. Hope this was also helpful for you. Yeah, any comments left in the chat, Alex?
I don't think so. We're just discussing
should...
about OP1, and so yeah, nothing in particular.
Yeah, but we are not finished yet, Alex. We have to
We're not
continue
finished
another
yet.
stream. Yeah.
Yeah, we have to continue, and to be easier for you, put the link here. So we will in a minute be online there because there we have the exam preparation. Sorry for the inconvenience of switching between the streams, but for us it's easier to link than a separate stream where people that just want to see the exam part don't have to go through the entire lecture. And so we have a dedicated YouTube link therefore that we can distribute. So we will be there in 1 minute, talk about the exam and everything related to the exam. So please make sure to be also there. Might not take too long, I think half an hour or so, and then we're done maximum, hopefully. But yeah, we also want to answer all your questions. So let's make sure to be there. Yeah.
Exactly. So this is the exam preparation stream is especially now for our date in 1.5 weeks. But of course, you can also watch it if you want to do the exam in January.
Right.
It is then the same schema for all the upcoming exams.
All the upcoming 6 exams this semester.
Yeah, exactly. So
this year, right? Not this semester. Sorry.
that would be much to do for us. No.
Too much for us. Yeah.
Yeah. Great. So thank you very much for being with us, and we will be live in 1 minute then in the exam preparation stream.
All right. Bye.